Hey guys, welcome back to another Kubernetes video. Today we will be talking about Kubernetes authentication, and we'll be looking through some of the different methods that Kubernetes provides for us to authenticate against our cluster. So let's start with an overview. First of all, what is authentication? Well, it's the process of verifying the identity of a user, and this is not to be mistaken with authorization. Authorization allows us to give permissions to a user. However, the first step is always to ensure that we know the identity of a user, and that a user who is trying to access our cluster is indeed who they say they are. And this process is carried out by the Kube API server, and there are a couple of types of users that we should be aware of. These are service accounts and standard human users. Now, Kubernetes, via the Kubernetes API, allows us to define and create service accounts, but it doesn't allow us to specify actual users. That's why you won't see any kubectl create user type commands. So all of the processing when it comes to standard human users is done at the API server, and we link the authentication information that we provide to particular groups or roles that can then be used to access different resources at the authorization stage. Now, we're going to go into a number of different methods of authentication that are available in Kubernetes. The first and most basic method of authentication is static password files. This has actually been deprecated, but I've included it just to provide a beginner's example of how authentication might work. So this is stored in a CSV file with password, username, and user ID, as you can see on the right hand side here. And we pass the basic auth file option when we are starting up the Kube API server. You can specify groups for users if required, and this would just go after the user ID, and you would specify the group, and then this would be used for the authorization stage. The next method is static token files, and this is similar to static username and password files, except rather than a password we are storing a token. So where you have the password 123, we just have a token, which should just be a set of characters in this field here. So as I said, it's a CSV file with token username, user ID, and optionally group as well. You pass the file using the -- token auth equals option, and this is how it's kind of specified. If we're running the Kube API server in a pod, then the command that will be run for the container is Kube API server, and we just have to pass these options as shown here: -- token auth file equal user tokens.csv, and it would be exactly the same when passing the -- basic auth file option for static passwords as well. Okay. Now, the next method of authentication is X509 client certs. So just take a little step back and give you a background on certificates in general. Certificates are generally used to authenticate a server, and this is often done to prevent man-in-the-middle attacks. So if you want to, say you want to log into Google, you don't want someone else to be able to impersonate Google, because if they can, that will allow them to take your login information and then use that to access your Google account. So the way that we authenticate a server is by using certificates, and the certificates are verified in terms of their validity using certificate authorities, and we as a client using our browser are aware of these certificate authorities. And so when we get a certificate back from a particular server, then we will know, then we'll be able to verify that, okay, this certificate was signed by a particular certificate authority, which means that is a valid certificate. The same applies in this case, except it is the reverse. We, as a client, are trying to validate our identity, and that is done using client certs. And in the case of setting this up, we have to specify the -- client CA file option when running the API server. So this here is where we specify the certificate authority that the API server should use to verify that the certificate we as a client have sent is indeed valid. As I said, the CA is used to verify the validity of a certificate, and I do actually have a little diagram here that we'll be able to use just to demonstrate how this is done on a very high level. So we're a client, we have a certificate that we use to validate our identity, but in order for the Kube API server to take our word for the fact that we are who we say we are, we first have to send our certificate to the certificate authority. Certificate authority will do what needs to be done to verify our identity. Then the certificate authority will sign the certificate using their private key, send that back to us, and then our signed certificate can go to the Kube API server, and the Kube API server will be able to validate that with their public key. Once that is validated, then we are now able to establish a authenticated connection between the Kube API server and ourselves, and then access the API however we would like, or however we're allowed to access the API. Okay. The next method that we're going to talk about is the bearer token method. In this case, we pass an authorization header within the request that we're sending, and that looks like authorization. The authorization header has a body of bearer and then the token itself. And if we want to use a bearer token with kubectl, then we do kubectl passer command and then -- token, and place the token that we have here in the command. Now, what would happen if we had a brand new cluster and we wanted to set up the cluster, but we don't have any of the permissions initially in order to configure everything that we want to configure? So this is generally done with bootstrap tokens, and these are a concept that Kubernetes have introduced to make the cluster setup process easier. So it's a type of bearer token for bootstrapping new clusters. And if we want to run this, again, another option that we have to pass into the Kube API server is -- enable bootstrap token auth and set it to true. The tokens are stored in secrets in the Kube system namespace. So these secrets we'll set them up in the Kube system namespace, and then they will be accessible by the Kube API server. You must enable token cleaner controller in the controller manager. So when you are configuring the controller manager, there will be another option that you can pass to the controller manager this time, and that will be -- controllers, and you will pass token cleaner along with all of the other controllers that you want to enable. And kubeadm, which is a popular way of configuring and bootstrapping Kubernetes clusters, uses this setting by default. Next is service account tokens. These are automatically enabled, and they use signed bearer tokens. Generally, a service account token, or a service account even, is configured by the API server itself and then associated with the relevant pods in order to access these different resources in the cluster. However, we can do this manually as well. And some of the options around setting up service account tokens are the service account key file. This is what's used to authenticate or ensure the validity of service account tokens when they are sent to the API server. The next is service account lookup. When this is enabled, the service account tokens that are deleted from the API are no longer valid within the Kubernetes cluster. They will no longer be permitted. They'll be revoked. And if we want to set up a service account token manually, what we first do is create a service account, and then we create the token related to that service account. And then if we want to send a request against the API with that service account token, we will just use the -- token flag, as I had mentioned prior. Let me see, this one here. When we're running kubectl, we'll just pass the token after that. Okay. The final method that I'm going to mention in this video is OpenID Connect tokens. So OpenID Connect is an extension of OAuth 2 that provides an ID token. This ID token is a JSON web token, and it contains known fields such as user emails and other information that are used to identify a particular user. So first of all, when you're using OpenID Connect tokens, you have to contact the identity provider to retrieve the JSON web token, and then use the ID token in the header to authenticate. So again, it's similarly structured to bearer tokens, where you pass the ID token in the header of the request that you are sending when you wish to authenticate. And this is how the flow would look. So you're an end user. First of all, you log into your identity provider. So this could be anything like Azure Active Directory or Google-based authentication mechanisms. The requirement here is that it supports OpenID Connect, and it will provide you that ID token when you make a request against it. Essentially, you just be providing your login information, and that will return a token, which you can then use with kubectl to request whatever resource you want to against the API server. So, as I said, you log in to your identity provider. That will return an access token, an ID token, and a refresh token. So the access token in this case isn't used. The ID token is what we use to contact the API server, and the refresh token is used to get a new token after our ID token expires. So we call kubectl. So once we have our token, we call kubectl with -- token, passing the ID token. Then kubectl sends a request with authorization bearer, again in the format that I mentioned for the bearer tokens, except this time we're just using our ID token. At the API server, this is where we validate the token to ensure identity. So we check, is the signature valid? Is the JOT expired? Is the user authorized? So at that point, we're asking whether the user can actually perform whatever action they've requested in the request that they've sent. If the user is authenticated, we'll perform the action and then return the result. That will come back to kubectl, and it'll be output to our terminal, and we will see whether our request has been successful or if it has failed. So that is the authentication video in this security series that I'm doing for Kubernetes. There will in fact be a part 2 to this, because there are 2 other methods that I haven't covered in this video, but I didn't want to make it too long, so I will upload the part 2 when I have that ready. I hope this was useful. Please like and subscribe. If you have any questions, don't hesitate to leave a comment. and I will talk to you in the next video.